This is our review for lessons 1 through 4, getting ready for our quiz. From number 1, find the f of 8. So I'm going to go f of, and I'm going to replace the x. Anytime I see an x, I'm going to replace it with an 8. So I see an x there, so that becomes an 8, and I see an x there, that has to become an 8. Now, this is just what I'm trying to find. Over here on the right side is the answer to what I'm trying to find. I got to multiply first, and then I subtract my 7. So the f of 8 is 33, or we could write the ordered pair. When x is an 8, the y is a 33. And I just continue doing that. So here comes number 2. I want the g of 6. I'm going to put a 6 in for x. All right, so I've got a multiplication there because this squared means to take x times itself. So multiplications, I always stick it in parentheses. Now this is like a grouping symbol. You have to find all the numerator first so you can divide that whole thing by 3. So you go 36 plus 9, haven't divided by 3 yet. That's 45. Now I divide by 3. That's a terrible looking 5. That's a bit better. And that goes into it 15 times. So the g of 6 is 15, or the ordered pair, x is 6, y is a 15. All right, so this is a quick way to find ordered pairs. So now I'm plugging in -9. So I got absolute values, -9, absolute values +1. So a lot of students mess this up. That's why it's on our review guide. So what this says is take 2 times whatever the absolute value of -9 is, and then add 1. So I still have to evaluate what's inside this grouping symbol first. So the absolute value of -9 is just 9. So this becomes a 2 times a 9. See, I've changed the absolute values to parentheses now because I've done the absolute value of -9 and replaced it with a 9. But I still haven't done my multiplication. So you could have just written here 2 times 9 if you wanted to, but I like to show my multiplications with those parentheses. All right, so that's 18 plus 1, or 19, or ordered pair, -9, 19. And the h of -9, we say then, is 19. Continuing on here. Now I'm putting an expression in for the x's. So I go p, and I'm just going to leave this blank there. Right, that's where I'm going to put my substitution. So I'm plugging in a minus 5 for this x, which means I've got to replace that x with a minus 5. So there's the substitution, and this is your answer, right? But lots of times we like to expand that. For right now, though, we'll just leave it like this, okay? I don't want to square that. That'd be a lot of work, because to square that, you'd have to write it twice, like this. And then you'd have to multiply these binomials together first, is the way you'd attack it. Remember, that's double distribution. So if you see this on the quiz, you do not have to do it. You can stop after that first step in this problem. All right, so then I would look for any like terms after I've done all of those multiplications, and these are like terms right here. That's all the like terms. But then I could distribute this 3 into all 3 of those. So we get 3a squared minus 30a's plus 75. That's a little future for us, though, of what we'll be doing. Go ahead and stop right there. Number 5, plugging in 6x plus 8. Now this one we're not going to stop on. All right, we don't have to square the binomial in this, and you'll see why in just a second. So there's my substitution in for x. That's this side of the equation there. Then comes my equal sign. I got a 1/2, but there's an x. So I'm going to replace that x with 6x plus 8. And then comes this minus 4 outside. All right, so this is still, this is 1/2. This is your x minus 4. It's just got x replaced. Now, this isn't easy. We got to distribute. I'm going to go upside down this time. Half of 6 is 3x. Half of 8 is 4. Half of 8 is 4. There we go. And those two 4s are like terms. And so the q of 6x plus 8 is just 3x. And we are done. Domain. Domain is just the x values. Right? This is a function. Functions are just things that give you ordered pairs, and this one's just telling us the ordered pairs. So our domain, we write these little curly brackets, and then I got a -5, a -3. So the -5 is the smallest one, the -3. Then will come the 0, then comes the 4, then comes the 6. Right? So we like to put them in ascending order, right? Lowest to highest. Let's do our range. Our range is just our y values. We like to put these in order as well. So it looks like -1 is the lowest. Get rid of him. Then comes 0. Get rid of him. Then comes the 2, the 3, and the 5. So there they are. Least to greatest. All right, I kind of get lazy on these curly brackets. That's how they're supposed to look. A little bit clearer than what mine are. All right, domain. So let's figure out the domain. So domain, what you want to do is you just look at the equation or the graph, and you're trying to figure out how much x's are used. So it's nice to find a feature of the graph that's easy to start at. So like this one has an obvious low point. So I check the right side. How far do you go to the right? See, I'm going this way. The only reason I have to go up is because the y value is dragging me up. So I could really just kind of trace to the right here, and every time I go to the right, I'm just checking, is there graph above me? And there is. There's graph above me for all these x's. This thing goes forever to the right, starting from this point. It also, though, does the same thing on the other side, so it goes forever to the left this way. So that's everybody. So my domain is all real numbers. Everybody gets used on the x-axis to make this entire graph. Remember, it goes forever. Okay. Now my y values don't quite do that. My y values, again, I look for a key feature, this low point. I go, hey, nobody is graphed below it. I'm looking at the y-axis now. If I go to -4, there's nothing graphed down here. So no y's use -4, or no points have a -4 y value, or a -3 value. The first y value that's used, the lowest one, is -2. And then this graph goes straight up the y-axis, right? It's always got points that have these y values. And it goes up forever. So the lowest point is down here. That's my low point. And it goes up forever. So we say it's all of the y's, where y is, in this case, greater than or equal to that low number. Alrighty. Over here, oh, this is a line. So I go left to right, domain. This thing goes forever to the left, right? It's going down, but it's going this way too. So it's going forever that way, it's going forever that way, all real numbers. And it's going up forever and down forever, all real numbers. That's true for all straight lines, unless they're horizontal or unless they're vertical. Then we'd have to think about it a little bit more. Let's see here. Determine the slope of the line passing through the given points. Draw the direction on the graph. If it's vertical or horizontal, state so. Alrighty. Let's find that slope. Right? x1, y1, x2, y2. And we're just finding the difference in the y's over the difference in the x's. x2 minus x1. This is changes in the y's over changes in the x's. What's that ratio? So 6 minus -3 over 2 minus -7. Got some double negative stuff going on. Right? If you need to, rewrite those. 6 plus 3. 2 plus 7. Get that number right. Hey, this slope is just 1. That's positive. This line goes up and to the right. Next one, slope. I'm not going to write them down now in x1, y1, x2, y2. I'm just going to go 5 minus -2. 4 minus 4. I get double negatives there, so that's 5 plus 2. 4 minus 4 is 0. Cannot divide by 0. That slope is undefined. I know this is a vertical line. Vertical line. I got to state that because it said to. All right, and 11 here. Note these y values are the same. That's a big clue of what's going to happen. 0 minus 0, negative 1 minus 5. Zero's on top, and that is okay. This is a slope of 0. This is a horizontal line. I know its equation. In fact, look at that thing. The y value is always the same number. That's the equation. Y is always 0. Y is always 0 is our x-axis. This one I know as well. Vertical line, these guys always have the same x values. So that's my equation. X is always 4. This guy goes right here where x is 4. All right, page 2. These don't take very long. All right, the height of a plant. So there's a function that tells me the height of a plant. It says find the rate of change from t is 3 to t is 7. All right, so here's my slope equation. It's going from 3 to 7. So I'm going to do the h of 7, that's the y value at 7, minus the h of 3, the y value at 3, over 7 minus 3, the change in the x's. So I calculate the h of 7 over here. 4 times 7 plus 9, I'm just using my equation there. 28 plus 9, 37. So I can start doing this over here, right? That's 37. That's what this guy is, minus. Got to find that h of 3 next. H of 3. 4 times 3 plus 9. 12 plus 9, 21. So it's 21 all over. This 7 minus 3, you could rake that a 4 at that point. So I do my subtraction. What is that? 16 over 4. 7 minus 3. That comes out to 4. Let's check out the units here. So this is my x. This is time in weeks. So my x, that's my denominator, right? This is time in weeks down there. Let's see, it gives me the height of the plant. It doesn't say how tall it is, though. Or what it's, oh, there it is, centimeters it's measured in. So that's my units of height there. So this units is centimeters per week. Hey, this plant is growing 4 centimeters per week between week 3 and week 7. That's its growth rate. Kind of cool. The area of a square with side length x in meters is x squared. Find the average rate of change of A as it goes from 2 meters to 6 meters. So same equation. This time we're going to be using the area function from 6 y value to the area at a 2 meter all over 6 minus 2. So let's calculate those y values. The a of 6 would be 6 quantity squared, or 36. The a of 2 would be 2 quantity squared, or 4. So my rate of change, or my slope, is a of 6, 36. Right there, that's what the a of 6 is. Minus the a of 2, which is a 4, all over 6 minus 2. I get 32 over 4, or I get 8. My numerator was my x, or was my y value, which is area. So that's meters squared per meter. So it grows in area by 8 meters squared for every meter you increase the side by. Kind of cool. Let's see here, number 14. Graph each of the following, show a minimum of 2 points. State the slope and y-intercept. All right, that'll be pretty easy to do. Here's my first equation. That is in y equals mx plus b form. So my slope is negative 3 over 4, and my y-intercept is 5. And I just graph that. Here's the y-axis. Where does it intercept? It intercepts the y-axis at 5. So it intercepts it right there. Let's make a big dot. And then its slope tells me, remember this slope is negative 3/4. it tells me how much the y changes per change in x. So for this line that we're trying to graph, excuse that, it changes, every time its y changes down by 3, its x has to change by positive 4. So it goes right there. Down 3, my y just changed down by 3, my x has to change positive 4. Now remember, this is just a negative number, so I could have done it this way. I could have said, hey, my y changes by positive 3, and I could have gone, change in y positive 3, and then my x would change by negative 4. 1, 2, 3, 4, put me right there. But that would still lie on the same line as the other 2 points. So there's my graph, right? And there's my slope, the negative 3/4, and there is my y-intercept, 5. All right, next one, y equals 2x minus 7, so my slope is 2. My y-intercept is negative 7. I'll make a big dot at negative 7 on the y-axis. And the slope of 2 means go up 2, but then your x has to change by 1, up 2 over 1. And we can go up 2 over 1 a few more times, right? I'm just going up 2 over 1. And there's my line. Helps have a program that straightens them out for you. But we had to show 2 points, so make sure you have like those 2 points. Just a pair of them. All right. 15, given the equation in standard form, answer the following about the graph. So this is that standard form, ax plus by equals c. Find the x-intercept. So to find the x-intercept, just think about the x-axis. Here would be an x-intercept, a point that crosses the x-axis. It would have some x number, but its y value you would know is 0. And so that's what we do. We let y equal 0. We plug it into the equation, and the 2 times y just comes out to 0. So your equation simplifies to this. You divide by 5, and you just found out when x is 2, y is 0, your x-intercept, where you cross the x-axis. And then we'll do the opposite over here. Now I want to find out where I'm at on the y-axis. So that one's x value I know. I know the x will be 0, so I let x equal 0. And I put it right there. The equation simplifies to this, and I get y equals 5. 10 divided by 2, and so when x is 0, y is 5, and that's my my y-intercept. Okay, so for x-intercepts, let y equal 0. For y-intercepts, let x equal 0. Put it in slope-intercept form. All right, so you're going to have to rewrite it. We'll show all our steps here. Slope-intercept form, remember, is y equals mx plus b. So we need to get the y alone on the left side. Right now, when I look at the left side, right here's my dotted line going down the center, or down the equal sign. When I look at the side with the y on it, I've got this plus 5x onto it, and the y is also multiplied by a 2. I first undo the addition, then I'll undo the division, or the multiplication rather. So I subtract 5x, and I subtract 5x from this side. I don't necessarily line it up under the 10 though, because these are not like terms. I do not want to add them together. I just want to write down what's left on the left side, and I want to arrange the right side with the negative 5x term first and the positive 10 term second. Now I just have to divide by 2 on everybody. Gets my y alone, and I'm in slope-intercept form. And don't worry about that fraction, negative 5/2. These are awesome because that's a slope. I know where this line starts on the y-axis, and I know it goes down 5 y's and then over 2 on the x as I go from point to point. D, what's the slope? We just got to grab those right out of the equation. It's negative 5/2, and it is a y-intercept of 5, or you could put 0, 5. All right, and I'm just grabbing that from the equation. All right, 16, 17, and 18, these are find the equations of the line. So, hey, they gave me a point, and it's not a y-intercept. This has to be 0 to be a y-intercept. It's not 0. So this is just a general point that's on the line, and my m is -3. So I'm going to use my point slope equation. That makes a lot of sense. Y minus my y value. My y value is -4. And I carry on here. Next comes my, let's see if we can find another color here. I wish this line was a little thicker, I think. There we go. Next comes my m, it's -3. X minus my x value, let's see, we'll use a pink color, my 7. There we go. So there's my setup. Then I scan the darn thing for two negatives bumped up right next to each other, and there's a pair of them. So I'm going to rewrite that. I'm going to say that's the same thing as y plus 4. And now I check the other side. There's no rewrite here. It's a single negative. So I can go ahead and distribute at this point. So -3 times x. And I see people drawing this arrow right here, but not doing that math. That is a -3 times a -7. Two negatives, when you multiply, make a positive, and 3 times 7 is 21. So this is plus 21. And now my last step, just get rid of that 4, and the y is now alone. And we are in that y equals mx plus b form. That tells me the slope is -3, and the y-intercept is 17. Number 17, find the equation of the line passing through. Oh, these are the tough ones, right? I've got 2 points, so I'm going to label them. I don't have a slope, so I'm going to calculate one. -1 minus 8 over 4 minus -2. Right, we're getting good at those, I hope. The bottom comes 4 plus 2. See, I just did the top, but the bottom I have one change to do. And then you have to simplify these things. Don't just stop when you get down to your fraction here. Check to see if they're both divisible by the same thing. Right, we're dividing them both by 3 in this case. That gives me a slope of -3/2. But now I'm ready to use my formula, because I have a point and I have a slope. Y minus my 8 equals my slope, x minus -2. So I'm going to have to do a little rewriting. I'm just changing that double negative now. I got to do that one step. Now I'm ready to distribute. There we go, get that red pen. So that's the easy one. This is the tougher one. But -3/2 times 2, I can divide first. Just comes out to -3. Now I should have brought down my left side there before I did all that math. But now I'm ready to get rid of that 8 and get that y alone. So I get -3/2 x plus 5. There we go. Last one. Equation of the line with a slope-intercept form with slope of m. So I know my slope. And I don't know just a point. I know the special point. And I can just write my form down, right? If I want a line that has that slope, it's got to have a 4/5 in that for the slope. And it wants to have a y-intercept of -2. There it is. And I'm done. All right, if you can do all those things, you'll be in great shape.